Hello everybody, this is a video solution to problem 3 from my fall 2021 Math 302 final at Cal State Fullerton. So in this problem we're given a commutative ring with identity and 3 ideals, A, B, and C, where we know that C divides A and C divides B. So quick reminder, in our class we defined divisibility of ideals in a way consistent with how Dedekind defined them originally. It's not really the modern way of defining it, but for our purposes in class, this was good enough. So C divides A if and only if A is a subset of the ideal C. So similarly here, C divides B if and only if C is a subset of the ideal B. So we want to prove that C divides the GCD of A and B, and the definition of the GCD of two ideals is the sum of those two ideals. So what that means is that we need to prove that the sum of the ideals A and B is a subset of C. And written this way, oh, we actually wrote this backward over here, didn't we? Look at that. B is a subset of C. So looking at this is actually pretty easy now. We know that A is contained in C and B is contained in C, and C is an ideal. Right? But if you're an ideal, that means you are closed under addition. And so that implies that A plus B is contained in C, because what is A plus B? These are all things of the form little a plus little b, where little a is in A and little b is in B. So if I know I have some little a in A, well, it's also in C, and some little b in B, well, it's also in C, right? Because we have these containments. But again, C is closed under addition, so little a plus little b will be contained in C. Okay, now what if we wanted the more modern version? Well, the more modern version, we would have defined C to divide A if and only if there exists some ideal, let's call it D in R, such that A is equal to C times the ideal D. And similarly, C is going to divide B if and only if there exists an ideal, let's call it E, such that B is equal to C times E. Okay, now we want to know whether or not C divides A plus B, which means we would have to write A plus B as C times some ideal. But from here, we can just add. We get A plus B is equal to CD plus CE. And now I can use the distributivity property of ideal arithmetic, so something that was on your homework, to factor out the C, and I get C times D plus E. And so look at that, A plus B is a multiple of C, and therefore, again, we would conclude C divides A plus B. All right, so there's kind of the old school version and the new school version. Good thing is it works in both cases. All right, everybody, we'll see you next time.